Hello and welcome to another online learning day today. Our focus for today, if we look at our essential question as we guide our learning, is how do I write the chemical name of ionic and molecular compounds? So, if we think of it as you already know how to write a formula if you're given the name, this goes the opposite because the reasoning here is that you need to be able to do both skills. Very basic skills for chemists. So, this is something that we just have to know so that the rest of the time we're in chemistry, when we're looking at chemical equations that have formulas or reading things that have chemical names, these are things that make sense to us. Because if you don't know what the formula means or you don't know what the chemical name means, it's pretty unlikely you can do whatever other thing you need to do with that chemical and with that formula. So that's why we need to learn how to do this today. All right, your bell ringer, what we'll do quick here together is we're going to review writing the formulas if we're given the name. So I'm going to walk you through the steps to remind you how we do this because we're going to learn how to do the opposite today, so this review might help. All right, so if you're given the name potassium chromate, the first thing you double check is potassium a metal? Look on the periodic table, it's on the left of that stair step line, way over on the left, so we know that I have to do the ion balancing rules to write this formula. So I look up the symbol and the charge of potassium, which is K with a +1. I look up the symbol and the charge of chromate. That 8 ending tells us we are not looking for the element chromium. We are looking for a polyatomic ion, looking on the ion guide sheet. So I find it on there and just copy it down. CrO4 with a -2 charge. Now we need to do a little bit of chemistry math. So this is a +1 and this is a -2. The reason these two things are coming together is that they're trying to make each other stable. Potassium gives away an electron to be stable. Chromate needs to gain 2 electrons to be stable. So if potassium can only give 1 electron away at a time, chromine's going to get its other electron from another potassium. So if I have 2 Ks, K+1 and another K+1, that will be +2, which will balance out the -2 of chromate. So then together you get K2CrO4. This is a stable compound. You don't need any parentheses because it's just an element and then one of this group ion. So together they make a neutral, stable compound. All right, how about this one? Trisulfur heptachloride. The element I'm dealing with here is sulfur. I look on the periodic table. Sulfur is on the right side of that stair-step line, so that means it's a nonmetal. So this means that I am not dealing with ions. This is not an ionic compound. It's a molecular compound, so they're sharing electrons. So I can't balance charges the way I did here. I just look at the prefixes. Trisulfur, tri, look on your ion guide sheet if you need to. Tri means 3, so there are 3. And then sulfur is capital S. So S3. Heptachloride, I recognize that chloride is an "ide" ending for the element chlorine, which is Cl. Hepta, I look on the ion guide sheet, the list of prefixes. Hepta means 7, so Cl7. So tri means 3, so I have in capital S. And then hepta means 7, and then the element is Cl, so it's just S3, Cl7. No balancing or math do we need to do because there isn't ions that are making this compound. These 3 sulfurs and 7 chlorines all come together, sharing electrons to make all 10 atoms stable. All right, let's try one more. Lead 2 nitrate. All right, so this Roman numeral 2 right away tells us that we're dealing with an ion. It also tells me the charge of this ion when it combines with nitrate. So lead, this you can look on your ion guide sheet if you need to. Lead is Pb, and the Roman numeral tells us that it's +2. Nitrate, not just nitrogen, because that would be nitride. Nitrate tells you you have to look on the ion guide sheet and copy it down. So Pb +2 for lead 2, nitrate, NO3 with a -1. This comes from the ion guide sheet. Once again, we got to do that chemistry math. A +2 means that lead is trying to give away 2 electrons to be stable. But this group ion, nitrate, can only take 1. It only needs 1 to be stable. So to finish this compound, you will need another nitrate that can take the other electron from lead. But then this is a group, so when we have 2 of them, we need to put parentheses around it. So the final answer will look like this. Pb, parenthesis, NO3, parenthesis, 2. Because you need 2 NO3s to balance out the 1 Pb with a +2 charge. So that's a little review of what we learned last time. And what we're going to learn today is I'm going to give you this formula, and then you're going to be able to tell us the name. So the idea here is that you'll be able to do both skills moving forward, basic skills that chemistry needs to know. And just to clarify, when I say that it's basic, it doesn't mean that it's easy. It just is something that all chemists need to be able to understand to keep moving forward through chemistry. All right, so our new topic for today is chemical names, the rules for naming chemical compounds instead of writing the formulas. We are still dealing with a binary compound. Bi, like bicycle, remembers we're dealing with two parts. Now, that's especially useful when we're writing the names because it will remind you that you can only have two names, a first name and a last name. You can't try to have middle names or extra names. So if you think it should have more than two names, that's a hint that maybe you need to use your ion guide sheet or you're making a mistake somewhere. So when you're taking notes today, if you want to kind of save yourself some writing, the stuff that I've underlined is the stuff that is most important. So we're starting with a metal plus a non-metal. Remember, and this is when we're not dealing with special metals from the ion guide sheet with Roman numerals. So just a first name, last name, metal, non-metal. Special metals, remember, are on that. They're the things that have the oxidation numbers, Roman numerals, on the ion guide sheet. I used to call it a Pete sheet. Sorry, that's why it says this, but I'm just referring to the ion guide sheet. So we're not dealing with any of these from the multiple oxidation numbers or ones with Roman numerals. So you start by just writing the name of the metal. So find the symbol, find the name on the periodic table, write it down. And then you're going to change the end of the nonmetal to "ide." All right, so you find whatever the nonmetal name was and you chop off the ending and call it "ide" instead. Why do we do that? So, like, for example, a common name you know is sodium chloride from table salt. That's maybe a name you've heard of. We don't say sodium chlorine. Why not? Why do we have to change the ending of an element to "ide"? It's how we know that the elements are bonded. If you say sodium chlorine, it sounds like you have two elements. When you say sodium chloride, it tells you that these two things have connected, they're bonded to make a compound. They're not just two separate elements. So, if you have a metal and a nonmetal in your formula, you write the name of the metal from the periodic table and change the end of the nonmetal to "ide." That's it. Let's try a couple examples. So Al2O3, I know that Al is a metal. You can find it on the periodic table. It's on the left of the stair-step line. O is on the right side, so this is a metal, non-metal. The first name is aluminum. The second element is oxygen, but I need to say it's bonded, so I'm going to change it to oxide. So the general rule is take the first syllable of the element, so oxygen would be ox, and then change it to ide, so oxide instead of oxygenide. You'll get used to that just by seeing more examples. Let's try this one. Zn. Zn is on the left of the stair-step line, so we know that Zn is a metal. It is not a Roman numeral metal, so the first name is just zinc. It's bonding to Cl. Cl, I look on the periodic table, is called chlorine, but I want to say that the zinc is bonded to chlorine, so I'm going to call it chloride. Zinc chloride. That's it. Okay, so you're thinking right now, do I have any questions? Does that make sense? First name, last name, maybe you've got it. If not, you're going to see more examples, and then if you have questions, you're going to ask. So first name, last name, binary compounds. That's it. Now let's add in some other details. What if it is a special metal and a non-metal? Okay. Start by writing the name of the metal like you normally would, like we did in the first one, but then we have to figure out what the Roman numerals are, and we're going to put that in parentheses. What we're going to look at is what charge was that original element based on what it's bonded to and what the subscript is. So how many of that element do you have and how many things is it bonded to? That's going to help us figure out the original charge, and we're going to put that in Roman numerals. And then we're going to again change the end of nonmetal to ide. So same way we ended it. So find the element name, take the first syllable and call it ide, like oxide or chloride. It's this Roman numeral business that takes a little bit of extra work for this type of a compound. So let's do some examples. So imagine that I had Fe2O3. Okay, well, Fe is, we look on the periodic table, it is a metal. And yes, it's a special metal, iron. How do we know it's a special metal? Look on your ion guide sheet. It has Roman numeral 2 or Roman numeral 3. Now, the thing we have to be careful of, this 2 does not tell you that it's iron with a 2 charge. This 2 says you need 2 of whatever iron this is to balance 3 of whatever the charge on oxygen is. So when you look at the period or look on the ion guide sheet, it could be Fe with a +2 or Fe with a +3. So then we would say, well, 2 times +2 would be +2. 2 times +3 would be +6. And it has to balance 3 oxygens. All right. So either I'm having 2 irons and the total charge is +4, or I'm having 2 irons and the total charge is +6. Well, how am I going to know which one? Well, remember, oxygen always has a -2 charge. That doesn't change, but you have 3 of them. So 3 times -2 is -6. So that means that I need it to be the iron 3 +6 to balance the -6. Having two iron 2s wouldn't balance it. That would not be a stable compound. So then the final name for this would be iron 3 oxide. Again, how did I figure that out? Iron with a +3 times 2 in the formula gives me a +6 charge. That balances out the 3 times -2 charge, which is -6, on the oxygen. So iron 3 came from that work I had to do. And you can do this in your head or write it out, whichever makes sense to you. And then it's oxide because it's oxygen. And I change the ending to say that it's bonded. So iron 3 in Roman numerals, oxide. Let's try another one. CuS. Cu, look on the periodic table. It is a metal. It's called copper. And I look on the ion guide sheet. It's either copper with a +1 or copper with a +2. I don't know the name of this yet, so I don't know which one it is. So I got to do a little bit of thinking. Well, I only have one copper in this formula. So it's either a total charge of +1 or a total charge of +2. So look at what it's bonding. It's bonding to sulfur. Sulfur has a -2. So that means it has to be copper with a +2 charge, one of them to balance one sulfur with a -2. Perfect match, giving away 2 electrons, taking 2 electrons. So copper 2 is what the name of this will be, bonded to sulfur, but I want to say it's bonded, so I have to change it to ending of ide, sulfide. So copper 2, Roman numerals to say that it's copper with a +2 charge, sulfide to say that it's bonding to sulfur. So that's the idea behind special metals, which means metals with Roman numerals, but then you end it the same way. So still a first name and last name. It's just you need the Roman numeral to tell us which version we're dealing with, and then you end it the same. First name, last name, nonmetals change to ide. Okay, that's the second version. So metals and nonmetals, either with Roman numerals or not, was the new thing that we just learned. Okay, see if that makes sense. Kind of think through what we did. If you're like, I think I get it, but I'm not sure, you're going to see some examples in the unit practice problems or on the homework for today, and then ask questions as needed. Why don't we take our first little break here? That's the first kind of big chunk of our notes. Write a level 1 question about any of our notes so far. Remember, level 1 comes right from the notes. So something like list the steps for writing a binary compound formula or name. That would be great, right? Or recite the steps, right? Because again, you're just giving an example of a question that you're going to review later. So recite the steps of writing the name of a binary compound. That would also be really good. All right. And you could also look on your Costa Questions guide that's on Schoology that has some other sentence starters if you feel like you're always getting stuck using the same thing. All right, let's keep going. So what if we're not dealing with a metal and a nonmetal? What if we are dealing with a nonmetal and a nonmetal? So our first 2 sets of rules were metal plus nonmetal. Now, what if we're combining nonmetal, nonmetal? So that means we're not dealing with ions, we're not dealing with charges, so we're not going to have to worry about Roman numerals, but we do have to figure out how to write these rules. We need prefixes. So prefixes will show you how many of that atom is joined together in the compound. And then you put ide on the second nonmetal, just like we've already did, like sulfide, chloride, oxide. That's the idea here. We don't put mono if there's only one of the first element. So if there was just one nonmetal to start with, you would just put its name. However, there is always a prefix, including mono, on the second. And you'll see an example like that, which we'll do together. So there's always a prefix on the second nonmetal. The only time there's not a prefix is if there's only one of the first nonmetal. It's just a naming rule that someone came up with and everybody followed. So we got to keep following it. Otherwise, what we write won't make sense and match other chemists. Let's do some examples. So S8I6. First, we realize that, yep, S is a nonmetal. I check on the periodic table. It's called sulfur. But I need to say that there's 8 sulfurs. So I look at the prefix list on my ion guide sheet. Octa means 8, so octa sulfur. I want to say that it's bonded to 6 iodine. So capital I for iodine. So 6, I look on the ion guide sheet and it says hexa, but I usually don't put vowels together. So instead of hexa-io, I'm just going to say hexio. And that's okay if you didn't know that. You will see that as you start seeing more examples. But then we don't want to say hexiodine. I need to say that it's bonded, so iodide. So put it all together. Octa, sulfur, hexaiodide. Oh man, look at how fancy you sound. If this makes sense to you, and if it doesn't make sense, you'll get it. You just have to practice some more. So 8 sulfurs, octasulfur. 6 iodines, but they're bonded, so hexaiodide. All right, that's the idea. Let's try another one. No, you don't want to do another one? Ha, just kidding. This is a formula. Let's go through the steps. N is nitrogen. There's only one of them. So the first name of this compound is just nitrogen. But we want to say that it's bonded to one oxygen. Mono is one, oxide. So nitrogen monoxide. So again, instead of putting monoxide or monoxide, we usually don't put double vowels together. So again, instead of hexaiodide, we just said hexaiodide. Monoxide for one oxygens bonded to one nitrogen. So notice we didn't put that prefix on the first nonmetal because there was only one of them. It's the only exception to our rules. Let's try one more. S2F5. Okay, well, we already did S. We know it's sulfur. We know it's a nonmetal. But this time there's only two of them. So look on your list of prefixes. Di-sulfur for 2. We want to say that it's bonded to fluorine. So we're going to say fluoride. But we want to say there's 5 of them. So we look on the prefix list. Penta. So di-sulfur pentafluoride. Disulfur for 2 sulfurs. Penta, because there was 5, fluoride. And then we did put that the vowel in there, instead of pent, because it makes it easier to say. Instead of pentafluoride, pentafluoride. And those little details, I wouldn't mark wrong. I would just correct them until you get to used to it. All right, so now think through that. Does that make sense? Okay, yep, prefixes are used in the name when they're 2 nonmetals. We learned that the other day when we did the opposite. If I gave you the name, these prefixes would have told you how many sulfurs there were. S8, I6 for hexa. All right, you have questions. You're going to try some of these examples today, and then you're going to ask for help as needed. All right, take your second break. So we're about 2/3 done with our notes. Do a level 2 kind of question. You could do something like a compare. Compare the rules for writing a molecular compound name versus an ionic compound name. That would be fine. Sketch a diagram to summarize the steps for writing a molecular formula name. Those are all things. But if you need some other guides of question starters, go ahead and look on that guide on Schoology. Pause the video if you need to. Come back when you're ready to move on. So the last part of naming compounds is, well, what if it's not just elements? What if it's polyatomic ions? Again, looking on your ion guide sheet to get the name. So find the name of the positive, whether it's a group from the polyatomic ion sheet or an element, write the name of the positive thing. Remember, if it's a positive element that is a special metal, don't forget about those Roman numerals. And then you write the name of the negative. So it could be an element or it could be a polyatomic ion. And remember, if it's a polyatomic ion, you don't change the endings. Like, for example, if you had NO3, that's called nitrate. That's defining it as NO3. If you change nitrate to nitride, you would change it from being NO3 to just being N. Because remember, ide endings are elements. Polyatomic ions from the ion guide sheet take the name that's already given them and usually ends in ate or ite. So remember, you never change the name of a polyatomic ion. You just copy it off the sheet. So the name of the first part, name of the second part. If the first part was a special metal, don't forget Roman numerals, but you don't put any prefixes on these because these are polyatomic ions, and you don't change the name, any part of the name, if it's a polyatomic ion. All right, so that is a really generic list of steps. So let's do some examples. How about this? Okay, now this is one of those times where remembering these are binary compounds is going to help you. It looks like there's 3 different things in here, but you can't have 3 names. It's binary, first and last. So that means some part of this must be on the polyatomic ion guide sheet, and it is. OH is on the guide sheet, ion guide sheet. So you look it up, it's called hydroxide. That means the first name is whatever Na is. Look on the periodic table, it's a metal. It's not a Roman numeral metal, so the first name of it is just sodium hydroxide. Why was it hydroxide? Because OH matches the ion guide sheet and the name is hydroxide. We don't change anything. We don't put prefixes on it because it's an ionic compound. First name, last name, that's it. How about this one? KClO3. Once again, this looks way more complicated than just 2 names, so some part of this must be on the ion guide sheet, and it is. ClO3 is on the ion guide sheet. You copy the name down, it's chlorate. That's how you know this is a ClO3 and not a Ci, because chlor for chlorine, and then the oxygen present is why it's chlorate instead of just chloride or chlorine. That means that the first name of this is just K. Look on the periodic table. K is potassium. It is not a Roman numeral, so just first name, last name. No prefixes, just first name, last name. Potassium chlorate. This came from the ion guide sheet. That's how you know the name of it. And we don't change anything about the name if it comes from the ion guide sheet. So you just copy it down, first name, last name. How about this one? CuSO4. Once again, some part of this must be on the ion guide sheet because I can't have three names. I look and I find, yep, this is. This is a polyatomic ion called sulfate. So I know that the second name is sulfate. The first name is Cu. Okay, well, what is Cu? Oh, it's copper. I find it on the periodic table. Oh, wait, but that's one of our Roman numeral metals. How do I know that? I look on the ion guide sheet. So here's where I have to go through those steps. Copper could either be a +1 or a +2. It's balancing sulfate, and there's only one of them. So sulfate, look on the ion guide sheet, is a -2 charge. One copper is balancing that -2, so it must be copper 2 sulfate. So the Roman numeral was needed to tell us it was the copper +2 charge to match the fact that there's just one copper balancing one sulfate. Because again, that 4 is just with the O. Total, there's just one sulfate, -2, balancing one copper, copper 2. Let's try one more. All right, so once again, some part of this must be on the polyatomic ion guide sheet, and it turns out that it's this first part, NH4. The name of this, just find it on the ion guide sheet, is ammonium, and it's bonding to chlorine, but we want to say it's bonded, so we're going to change the ending, chloride. Ammonium chloride. So what we changed about our rules is, instead of just having two elements, which were either nonmetals and nonmetals or metals and nonmetals, we had an element and a polyatomic ion, an element and a polyatomic ion, a special element metal and a polyatomic ion, or polyatomic ion and an element. So think through those steps. Does that make sense? If you're like, I think so, but I'm not sure, you can do the unit practice problems and check answers to get immediate feedback to show what you do or don't know. You can also ask for help as needed. All right, so there's two things you're always going to check when you are doing these names. Prefixes are only used if both elements are nonmetals, and Roman numerals are only used in a name if you have a special metal. So don't try to put prefixes in extra places in names. Don't try to put Roman numerals anywhere except the name of a special metal. And there's only a few of them. If you look on your ion guide sheet, there's not that many. Yeah, there's a bunch. There's chromium and copper, and there's lead and tin. Those are the ones we use the most. So there's a few more on there. Just realize that you only put Roman numerals in names. That's one of the things that's really tricky about this formula writing and naming. Once you know all of the rules, it's easy to get them all mixed up. So you just have to keep practicing. So again, prefixes are only used when you're dealing with nonmetals. Don't try to put prefixes on a metal. And don't try to put Roman numerals in a formula. Don't try to put Roman numerals with anything except a special metal. So again, it's a lot to remember. If you're feeling frustrated or feeling full of so many rules, it's just because it's new and you got to practice. If you feel like, no, this is fine, awesome, great. But if you're feeling frustrated, don't stay frustrated. Start to practice, ask for help as needed. So that's the end of our notes. So go ahead and take your last brain break and do a level 3 kind of question. Sometimes with some of these kinds of really specific types of notes, defending or arguing why we need to learn this sometimes helps your brain think about it and get your brain in a right spot for moving forward. All right, that brings us to the end of Unit 2, Day 4. Here's your to-do list. In a perfect world, here's what you'll be working on today, finishing up before our next class. If you didn't already do so, finish your COSTA questions, and then now write your summary. The summary should answer the EQ. Did you learn what you were supposed to learn today? Now you can finish the formula and naming practice assignment. So remember, you did the first page, which was writing formulas, earlier this week. Now you can do the second page, which is writing the name. If you haven't started it at all, that's fine. That'll help you review the formula part from the other day and also the new stuff. If you feel like you're not ready to do the practice assignment, you can, of course, do some unit practice problems, 29 through 42, and then that will give you, you can check the answers to see if you're doing it right if you want to before you start on the graded assignment. Or, of course, you can come to office hours. You can come to your next Zoom class, ask questions as needed. All right. So thanks so much for listening as we continue to learn some basic skills to help us move forward as chemists. See you next time. Bye.